Hi everyone, this is the first video on the topic of height and distance. Now what is height and distance? Well, this is actually an application of trigonometry and the properties of triangle. So this is not a separate topic as such. Usually this is part of the trigonometry chapter, and here we are going to learn a few fundamental concepts that will be useful while calculating the height and distance of various objects. For that, first we are going to learn the line of sight, the angle of elevation and angle of depression, and after that we will talk about bearing. So let's get started. Let's suppose we have a ground level horizontal line, which is the light green dotted line, and also let's suppose we have an object at point P. And let's suppose we have an observer who is at point A, and from point A the observer is looking at the object which is at point P. So the green line with an arrowhead will be the direction of the way the observer is looking towards the object which is at point P. So this green line is actually called the line of sight, because in that direction the observer is looking at the object. And because the object is at a higher level, this line of sight will make an angle with the ground level horizontal line, and let's suppose that angle is theta, and this angle is actually called the angle of elevation, because this angle is kind of a measurement of how high the object is from the ground level, right? So that is why it's called the angle of elevation. It kind of indicates how much the object is elevated from the ground level. And if we drop a perpendicular from P onto this ground level horizontal line, let's suppose it landed at point Q, so PQ will be considered the height of the object from the ground level. Now if we interchange the positions of the observer and the object, let's suppose now the object is at point A and the observer is at point P, then what will be the situation? Well, then the line of sight will be exact same line, just the direction will be opposite. In the second case, the observer being at point P, the observer will be looking kind of downwards towards the object which is now at point A. So the line of sight will be exact same line, just the direction will be towards the downward direction. And here if we draw a horizontal line through the point P, then the line of sight will make an angle with the horizontal line, which is the yellow dotted line there, and that angle is actually called the angle of depression. It kind of indicates how far down the object is from the observer. The observer is assumed to be at a higher elevation and the object is assumed to be at a lower elevation. So that angle, the yellow angle theta, that is called the angle of depression. And if you think about it, the yellow dotted line and the light green dotted line, both lines are actually parallel because they both are horizontal. And if you consider AP to be a transversal between two parallel lines, then the angle of elevation and angle of depression, they will be the two alternate angles and they will be equal. So whenever we interchange the position of the object and the observer, the angle of elevation and the angle of depression, they are exactly equal. I hope it is clear up to this point. Next, we are going to talk about bearing. Now, bearing is a term which is used in navigation. In navigation, there are various conventions of indicating the direction of a moving object. We know that a magnetic compass is used in the navigation, and in the compass we have cardinal directions or cardinal points, and in navigation on the compass, north is the most important direction. Now what is bearing? Well, bearing is actually the direction of a moving object. Now if we want to talk about the direction of a moving object, we need to have a reference direction, and from that direction we can measure a certain angle to indicate the direction of the moving object, right? And also we need to be clear about another thing, that when the object and the observer, they both are on the same level, that is where this bearing comes into play. Because in the previous case you have seen, when the object and the observer, they were at two different levels, then we could indicate that with the help of angle of elevation or angle of depression. But in the second case, where now we are talking about both the observer and the object being on the same level, let's say the ground level, there somehow we have to indicate the direction of a moving object, and for that we are going to use this concept of bearing. Now north direction is of course taken as a reference direction, and there are actually two conventions to indicate the bearing, which is nothing but the direction of a moving object. So bearing is actually the direction of a moving object. Now what are the two methods of denoting the bearing of a moving object? Well, in the first method, the north direction is taken as the reference direction, and in the second method, north and south they are taken as the reference directions. Even though there are 4 cardinal directions, only north and south would be taken as the reference directions. Let's take a few examples here. So in the first method, we are going to use the reference line here, which is pointed towards the north direction. Let's assume that this is our reference direction in the first method. And in the second method, let's assume that the north-south direction would be taken as the reference direction. And also I have drawn a horizontal line to indicate the east and the west directions, but north and south would be used as the reference directions for the second method. Now let's suppose we have an object which is moving kind of like this. The object is moving at an angle of 30 degree from the north direction. In the first method, when we express the bearing, we have to write it like this. We have to say the bearing is equal to 30 degree, which will mean that the object is moving at a direction which is 30 degree from the north, and it is always measured in the clockwise direction. So in the first method, the angle could be from 0 to 360, anywhere between 0 to 360, and it will be written as just purely an angle like this. It will always be assumed to make this much of an angle from the reference direction, which is the north direction. Now in the second method, how would we write the bearing for that same moving object? If we have to express the bearing in the second way of doing it, then the bearing can be expressed like this. It should be denoted as north 30 degree east. So now there will always be east or west after the angle, and before the angle it will always have a north or south. And we'll take a few examples, we'll see how that works out. And in the second method, the angle will always be an acute angle. The angle will of course be measured either from the north direction or the south direction. In the clockwise or anti-clockwise does not matter, but it has to be an acute angle, and it has to be measured from the north direction or south direction. So in this particular example, as you can see that the bearing of the moving object in the second method should be expressed as north 30 degree east. That means the angle has been measured towards the east side from north. So north is the reference direction here, and 30 degree away from the north towards the east is the direction in which the object is moving. I hope it is clear up to this point. Let's take a second example. Let's suppose we have an object kind of moving in this direction here. So in the first method, what would be the bearing? Well, in the first method, the bearing will be 135 degree, angle measured from the reference direction, which is the north direction. So in the first method, the bearing can be denoted as 135 degree. But how about the second method? Well, if you think about it, in the second method, the angle has to be an acute angle. So in this case, we really cannot measure the angle from the north direction. Here we have to measure the angle from the south direction because it is much closer to the south direction than the north direction. So in this case, how we have to denote the bearing? Well, it will be south 45 degree east, because the angle is being measured from the south direction and also it is towards the east. So we say that the angle has been measured with south direction being the reference direction, and then it is moving at an angle 45 degree towards the east, not towards the west, because it is moving at 45 degree angle towards the east from the south direction. So the bearing has to be written like this, south 45 degree east. Now let's take another example. Now let's suppose we have an object which is kind of moving like this. The starting point of the moving object is always taken as the center of the compass. So in this case, if you look at the first method, there the bearing of this moving object would be 240 degree. And how about the second method? Well, in the second method, as you can see, we cannot use north direction as the reference direction because the object is much closer to the south direction. So we have to use south as the reference direction. So in this case, the bearing would be south 60 degree west, because the angle has to be measured with south direction being the reference direction, and then it is actually moving towards the west, not towards the east. It is actually moving towards the west. So we have to say south 60 degree west. I hope it is making sense. And we're going to take another example in the fourth quadrant. Now let's suppose we have a moving object which is kind of moving in a direction like this. In the first method, the bearing of course will be 315 degree. And in the second method, how we need to denote the bearing? Well, now we have to measure the angle from the north direction because it is much closer to the north direction than the south direction. Because you always have to remember that the angle will be an acute angle in the second method. So in this case, what will be the bearing of the moving object in the second method? Well, it will be north as the reference direction, then 45 degree towards the west. It is not going towards the east, it's actually going towards the west at an angle of 45 degree. So you have to say the bearing of the object would be north 45 degree west. And if the object moves in one of the cardinal directions, then we really don't need to denote that with an angle. We can say the object is moving towards north, or the object is moving towards east, or the object is moving towards south, or the object is moving towards west. And in the first method, of course, the bearing would be 0 degree when the object is moving towards north. The bearing will be 90 degree when the object is moving towards east. The bearing would be 180 degree when the object is moving towards south. And the bearing would be 270 degree when the object is moving towards west. The second method is usually the more popular way of indicating the direction of a moving object, and you will usually see that the direction is being denoted using the second notation method, where we first indicate what was the reference direction, then how much angle, and then towards east or west. In the next video, we are going to take some examples, very interesting examples, to see how we can solve problems for height and distance. This brings us to the end of this video. I hope everything made sense. Thank you for watching. See you in the next video.